So, remember our brilliant solution for running an American 110 volt Bambu lab printer here in Europe without replacing its internal heaters? We simply added this 5000 watt transformer and look. Wait, what just happened? Why did a printer that takes well under 100 watts to boot up just black out half the house? I'll explain the hidden physics behind this in a sec and show you our $15 DIY fix for it, including an accidental surprise discovery that makes this whole setup infinitely safer. I'm gerGO, and welcome to gerGO Print 3D, the YouTube channel where my young nephew Levi and I have the time of our lives breaking and fixing the coolest tech on earth. We are delighted to have you join us. To make your experience the best, all our videos feature curated, translation-ready subtitles, chapter markers, and audio tracks in many languages. If you haven't seen part 1 of our Bambu Lab adventure, click right up here to catch up. It's an intriguing story of generosity from a fellow YouTuber. We successfully paired our 110 volt American printer on our 220 volt European network using a massive 5000 watt transformer, but it came with a very puzzling symptom. About 1 out of every 5 times we flipped the switch, it instantly blacked out half my house. The printer only takes about 100 watts in idle, less than a standard filament dryer, so what exactly is going wrong? I did a little research and it turns out we were losing the AC sine wave lottery. That giant transformer is basically a massive coil of wire wrapped around an iron core. When you turn it on, it needs an enormous instantaneous gulp of current to create its magnetic field, known as magnetizing inrush current. If you flip the switch right when the AC voltage wave is near zero, you're fine. But if you happen to hit it at the absolute peak of that wave, the core saturates, acts like a dead short, and pulls a colossal current spike that instantly trips your breaker. The theoretical solution is simple. We need a soft start circuit to buffer that initial electrical punch. Now, we could build a custom circuit board for this with the help of our sponsor PCBWay, which would make total sense if I were preparing to mass produce a sleek, out-of-the-box solution. PCBWay specializes in fast custom PCB prototyping, offering everything from simple bare boards in 24 hours to complex 60-layer designs. You just upload your files for an instant quote, and they provide complete turnkey assembly, automatically sourcing and installing all your SMDs, through-hole components and relays before shipping it straight to your door, here in Hungary or most anywhere on Earth. There are just 2 reasons I didn't do it like this. A, I honestly have no idea how to design a circuit board from scratch. And B, a high-power soft start module is actually an off-the-shelf component available from multiple sellers, even on AliExpress. I will put the link to the one we chose, along with the other components for our complete solution, in the description below. But if you ever run into a similar issue where turnkey solutions are harder to get, PCBWay is absolutely the way to go. Be sure to use our link down below for a little discount on your first order. A week or 2 later, we had all the parts for our custom professional grade solution. Taking them out of their package, we have a standard 220 volt socket. Then of course the star of the show, the 5000 watt soft start board. But also these panel mount fuse holders, because here in Europe with our reversible plugs, double pole fusing is the absolute safest way to go. Now we already had this heavy duty rocker switch, which turned out to be a bit less than ideal, but as you'll soon see, it worked out great by the end. With the physical components on the desk and my digital calipers in hand, I fired up FreeCAD to design a safe and practical enclosure. Because we are dealing with mains voltage here, a proper case isn't optional, it's a strict requirement. In the digital design, I created internal standoffs to securely mount the soft start board right at the bottom. On the top panel, I made precise screw holes to mount the power socket and the master rocker switch. I gave the two fuse holders their own dedicated spots right next to the power input cable, ensuring they are the very first things the electricity hits when it enters the box. I designed holes into the case for the internal wiring, two from the switch to the fuses, and an elongated slot for another two wires coming from the soft start module to the socket. I also made sure to add ventilation slots along the sides. The resistors on the board absorb a lot of energy and generate a quick burst of heat during that initial power surge, so they need to breathe. These holes also serve another purpose. We will be able to check the board's internal status LED at a glance without ever having to open the box. With the CAD model finished, it was time to bring it to the real world. But as you know, we rarely get it perfect on the very first try. To line up the screw holes and check tolerances as fast as possible, I printed a few prototypes on our lightning fast FS1 S1 Pro. I stopped the early drafts after just the first couple of layers. These let us adjust dimensions, but even this complete PLA draft printed in a matter of minutes, allowing us to immediately test the fit of all the components. I still needed to move a few screw holes and adjust the clearance for the fuse holders, and I was able to use these draft prints as templates to drill holes for the internal wiring on the switch and socket. For this, I grabbed our then new hot tool 16 volt brushless drill. It has plenty of torque, but is compact enough for precision tasks. Now, plastic and metal shavings inside high voltage electronics are recipe for disaster, so I immediately cleaned up the debris with the hot tool auto care mini vacuum. Even if I accidentally suck up a screw or a tiny component, it is way easier to fetch it from the little debris collector than the dust bag of a big household vacuum. These are some of our absolute favorite workshop tools, and we have a 15% discount code for them in the description below. With the modifications done and the design perfected, it was time for the final production part. Because this box handles mains voltage and will generate some heat, I did not want to print it out of PLA. Even though our enclosed and heated SVO8 Max is now ready for ABS, these parts fit perfectly into the smaller Bambu H2S, so that's the one we went with. I loaded up some Creality Hyper ABS, and as you can see, we caught the ABS fumes using the same Tuca smoke purifier I showed you with the Max in our dedicated video right up here. The print came out flawlessly, but here's a painful test of patience when printing ABS parts. After the print finishes, you can't get to it. You have to leave the printer door closed and let the part cool down slowly inside the chamber. If you take it out while it's hot, the sudden temperature drop will cause it to warp and even crack along the layer lines, making the lid impossible to close, for example. Once it was safely cooled, we were ready to build. Here we go again. I used our DIY stealth press to sink the brass heatset inserts into the casing. It just makes the assembly so much more satisfying and ready for multiple reassembly, you'll see. Then I fastened the fuse holders inside, prepared my heavy gauge wires, and mounted the external switch and socket. Next came the internal input wiring. I lead the live and neutral wires to the fuses and the ground directly to the socket. But hey, I realized the socket was mounted the wrong way around. The ground connection terminal needed to face the switch for the wiring to fit cleanly. Oh well, we make mistakes, so you don't have to. After correcting that, I finished the internal output wiring. connected the main external input cable. And carefully wired the soft start board into the circuit. I closed up the box, double checked everything, plugged it in, flipped the switch, and nothing. No power, no lights, just dead silence. I sat there scratching my head for a minute before I realized I completely forgot to actually put the glass fuses into those fuse holders. Like I said, multiple reassembly is not unheard of in our workshop. With the fuses finally in place, I decided to test it with a simple desk lamp first. I flip the switch, the lamp turns on immediately, but then about 2 seconds later, we hear a distinct click from inside the box. That click is the magic of the soft start. It means the relay has engaged, bypassing the resistors and opening up the full power flow. It works. It was finally time for our ultimate test, plugging the massive V4 transformer and the Bambu lab printer into our new device. But first, we have to change our habits. From now on, the big transformer and the printer both need to be left permanently in the on position. We will use the rocker on our new soft start module as the single master switch for the whole system, and this is actually a huge upgrade in convenience since the printer's own switch is hidden annoyingly on its back. But there's a risk. That giant blue breaker on the transformer is just too inviting. If someone turns it off and then flips it back on while our soft start module is already active, we completely bypass the protection. We would be right back to square one with a massive inrush spike and the blackout lottery. To stop this from happening, I switched the transformer to the on position and printed this cute informative cover. It physically blocks the breaker to prevent me, Levi, or anyone else from accidentally going around the slow start module. By the way, I have uploaded the STL files for both this safety cover and the custom soft start enclosure to my Cult 3D page, link in the description. If you appreciate us sharing these designs and figuring out the wiring so you don't have to, please hit that like button and consider subscribing. You won't regret it, and it really helps the channel out. So with the cover in place, we were safe, or so you'd think. But as I was setting it up, I was still worried about one specific detail in my wiring. Now I know all the electricians watching are probably screaming at their screens right now, typing in the comments, gerGO, you used a single pole switch. In Europe, you should use a double pole switch. And you're 100% right. Let me know in the comments if you spotted that. Because our wall plugs are non-polarized, meaning you can plug them in upside down, a single pole switch gives me a 50-50 chance of breaking the neutral wire instead of the live one. And that would leave the internal components dangerously energized even when the switch is turned off. But I plugged it in anyway, made sure my new switch was in the off position, and then I noticed something strange. The power light on the V4 transformer was blinking. I unplugged the box from the wall, flipped the plug 180 degrees, and plugged it back in. And the blinking stopped. We accidentally stumbled onto the most elegant safety feature imaginable. When the plug is in the wrong orientation, the switch breaks the neutral wire, but the live voltage still reaches the transformer's internal power supply. It doesn't have enough power to turn it on fully, but capacitive coupling allows a tiny amount of leakage current to slowly charge the LED, causing it to blink. I actually researched this and learned it's called phantom power. When I reverse the plug to the correct orientation, the switch breaks the live wire right at the entrance, exactly after the fuses. The entire circuit is dead and the status light stays off. No markings needed, no guessing. The blinking light is a built-in foolproof indicator that tells us exactly when the system is plugged in safely. Don't we love it when a problem solves itself? With the power smoothed out and our safety guaranteed, Levi and I could get back to printing on our H2S. Just look at that smooth startup. No sparks, no blackouts, just the hum of the fans. This is actually our first time trying filamentree filaments. We received some red and black matte PETG, and black, white, and yellow PLA. If you know Levi, you might have a hunch about what we are planning to print with these colors.
Like a plastic smell, but...
Can I smell? Not there. Put your guesses and maybe your blackout stories in the comments below. Unwind, but something didn't work. I just have to somehow untangle this and it will be able to continue with this. But everything will be revealed next week. Make sure you're subscribed so you don't miss it. You can find links to all the tools and components we used today in the description below. And if you want to catch up on the first part of our Bambu Lab journey, which couldn't have happened without our friend Igor from MyTechFun, click right here. Or see all the cool Sovol upgrades we carried out recently in this playlist. Let's go print 3D. Thank you for watching another gerGO Print 3D video all the way to its end. Stay safe.